Hi, I'm Mr. John B. Florendo, your grade 8 Algebra 1 teacher. Today, we will discuss about the Pythagorean Theorem in Chapter 10, Lesson 1, that is on textbook pages 614 to 618. Materials needed. First, your textbook. Second, notebook. Third, ball pen or any pen. Our objectives: first, state the Pythagorean theorem. Second, use the Pythagorean theorem to find the missing part in any right triangle. Third, solve problems using Pythagorean theorem. Fourth, identify right triangles using the converse of the Pythagorean. Before we discuss, let's state first what is a Pythagorean theorem. Pythagorean theorem states that in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. In symbols, we can write this one as a squared plus b squared equals to c squared, wherein the sides forming the right angle are the legs, and it is represented by A and B. The side opposite the right angle is the hypotenuse, which is the longest side in any right triangle. In addition to that, that Pythagorean theorem was named by a Greek mathematician, Pythagoras. You can use the Pythagorean theorem to find the length of a right triangle's hypotenuse given the lengths of its legs, or given the length of the hypotenuse and one of the leg to find the other legs, and vice versa. Let's take this first example. Finding the length of a hypotenuse. Find the length of the hypotenuse of the right triangle in this figure. First, let's identify first the given in that illustration. We are given here the length of the legs. What are the lengths of the legs? We have 5 and 12. The missing length of the right triangle is the hypotenuse. So using the Pythagorean theorem that states the square of the hypotenuse is equal to the square of the leg plus the square of the other legs. What is the length of the hypotenuse? In the illustration, it is denoted as x. So we're going to plug that one into the Pythagorean theorem. So x squared equals to, what is the length of the leg? 5 squared plus, what is the length of the other leg? 12 squared. Simplifying that one, we will have x squared equals to 25 plus 144. Combining the right side, so we will get x squared equals to 169. So we want only here to find for the value of your x. To find for the value of your x, take the square root of both sides. So x equals to 13. Because the side lengths are 5, 12, and 13 are integers, they form a Pythagorean triple. So in the last part, we will discuss about this Pythagorean triple. Let's proceed to the next example. What if you have a radical in the right triangle as this figure? What are the given? We're given here the lengths of the legs, and what is the unknown? The missing part of that right triangle. We have the hypotenuse. So again, using the Pythagorean theorem, the square of the hypotenuse is equal to the square of the leg plus the square of the other leg. What is the length of the hypotenuse? In the illustration, it is the x. What is the length of the legs? We have square root of 20 and 4. So simply substitute that one into the Pythagorean theorem. So we will have that one, the square root of 20 raised to the second power plus the square root of 4. So simplifying this one, we will get x squared equals to 20 plus 16. So combining like terms here, 20 plus 16, so that is x squared equals to 36. So take the square root of both sides, so x equals to 6. Why would you not need to answer with 6 and negative 6? Because lengths can't be. Another example. Find the length of the leg of the right triangle as illustrated below. Let's identify first the given. We're given for the length of the hypotenuse, that is opposite of the right angle, which is 10. And then one of the legs, that is 8. And the missing one is the other leg. So again, using the Pythagorean theorem, the square of the hypotenuse is equal to the square of the leg plus the square of the other leg. Substitute the given that we have in the right triangle into the Pythagorean theorem. We will have 10 squared equals to x squared plus 8 squared. Simplify both sides. We will have 100 equals to x squared plus 64. So using the subtraction property of equality, we're going to subtract both sides by 64. So 100 minus 64, that is 36. 64 minus 64, that is 0, plus x squared, you will get that one as x squared. Take the square root of both sides, so x therefore is equal to 6. Another example. Let's say this right triangle. What are the given and what is the missing in this right triangle? We're given here one of the legs and then the length of the hypotenuse, and the missing one is leg. So again, use the Pythagorean theorem. Square root of the hypotenuse is equal to the square root of the leg plus the square of the other leg. What is the length of the hypotenuse in the right triangle? That is 13. So 13 raised to 2 equals, what is the length of the other leg? We have 12. So 12 squared plus, what is the other leg? We have x squared. Simplifying that one, that could be square root of 13, that is 169. Square root of 12, that is 144. The square root of x, that is x squared. So again, apply subtraction property of equality. Subtract both sides by 144. 169 minus 144, that is equal to 25. 144 minus 144, that is 0, plus x squared, you will get x squared here. Take the square root of both sides here. So x therefore equals to 5. When would we use the Pythagorean theorem? Let's take this problem. John leaves school to go home. He walks 6 blocks north and then 8 blocks west. How far is John from the school? So first, to solve this problem, we can illustrate first this problem. Let's say, for example, this is your school. Okay? So it says John walks 6 blocks north. So going north, that one, that is 6 blocks already. And then John walk 8 blocks to the west. So you will have this illustration of this problem already. So let's define first the variable that we're going to use in this problem. The distance from school to home is actually the hypotenuse in this problem. So let's define that one as your C, the missing distance from school to home, wherein your A is 6 and your B is 8. So simply plug that one into the Pythagorean theorem. C squared equals to A squared plus B squared equals to C squared. What is the value of your A? That is 6 plus 8 squared. Simplify the right side. C squared equals to the square root of 6, that is 36, plus the square root of 8, that is 64. Combine like terms in the right side, so that is C squared equals to 100. So take the square root of both sides, so C equals to 10. So the distance from school to home is 10 blocks. Another example. TVs are measured diagonally. If your home TV is 24 inches tall and 36 inches wide, what is the length diagonally of your TV? So to solve this problem, we can illustrate by drawing. Let's say, for example, this is your TV. It says already that in your TV, it was 36 inches wide and 24 inches tall, which is the height of your TV. We are asked here, what is the length of the TV, the diagonal length of the TV? So to solve this kind of problem, we will just use the Pythagorean theorem that states again, a squared plus b squared equals to c squared. What are the given in that illustration? Take note, this one is a right triangle. So that 24 and 36 inches represents the lengths of the legs in your right triangle. So therefore, you will have that one as a, that is 24a squared, plus b, that is 36 squared, equals to c squared. Simplifying the left side, that could be 576 plus the square root of 36, 1296, equals to c squared. Combined by adding the left side, 576 plus 1296 equals to 1872, and then take the square root of both sides. So you will get c equals to 43.266. Therefore, the TV is about 43.3 inches long. Another one. In a triangle, if c squared equals to a squared plus b squared, then the triangle is a right triangle. In a diagram, let's say this is your right triangle, denoted as ACB. Then, opposite of your B, that is your A, and opposite of the angle A, that is the length of B, and opposite of the angle C, which is the length of the side, that is C. If that is true, C squared equals to A squared plus B squared, then, therefore, the triangle ABC is a right triangle. The converse of the Pythagorean theorem states that if the square of the length of the longest side of a triangle, which is your hypotenuse side, is equal to the sum of the squares of the lengths of the other two sides, which is your legs, then the triangle is a right triangle. You can use the Pythagorean theorem and its converse to determine whether a triangle is a right triangle. If the side lengths satisfy the equation a squared plus b squared equals to c squared, then the triangle is a right triangle. If they do not, then it is not a right triangle. Let's take this example. Determine whether the given lengths can be side lengths of a right triangle. What are the given lengths of a right triangle? First, we have 12 centimeters, 16 centimeters, and 20 centimeters. Let's identify first what are the corresponding lengths of your A, B, and C in a right triangle. The C is always the longest side in a right triangle. What is the biggest length of sides in this three? We have 20. So therefore, C is equal to 20. Your A is 12, your B is 16. So just simply plug that one into the Pythagorean theorem. Squared of your C, that is 20 squared, is 400. Squared of your A, that is 12, that is 144. Squared of your B, that is 16, is 256. So add that one. Squared of 12, that is 144, plus the square of 16, that is 256. Add these two, that is 400. If that is equal to the square of the hypotenuse, then therefore, it forms a right triangle. Is that equal? Yes, it is equal. So therefore, 12 cm, 16 cm, and 20 cm are the length side of a right triangle. Another example. 8 meters, 10 meters, 13 meters. What is the first step here? To identify what is our C, and the remaining are your legs. What is our C here? That is 13 meters, correct? The biggest number in the three. So, square your A. The A here is 8. What is the square root of 8? 64. What is the square root of B? We have 100. Add them. 64 plus 100, that is 164. Is that equal to the square of your C, which is 13? What is the square root of 13? It's 169. Is 164 equal to 169? No. So therefore, 8 meters, 10 meters, and 13 meters will not form a right triangle. The Pythagorean triple. A set of three positive integers a, b, and c that satisfy the equation a squared plus b squared equals to c squared. Let's say, for example, the integers 3, 4, and 5 form a Pythagorean triple because the squared of 3 plus the squared of 4 is equal to 5 squared. If that would be the case, then those integers 3, 4, and 5 form a Pythagorean triple. What are the other examples of Pythagorean triple? You could have that one: 6, 8, 10, 5, 12, and 13, 7, 24, and 25 form a Pythagorean triple. For the other exercises, you can have that one into the Pearson account.